Alright, so in this video, we're going to go over the basics of data structures, and this will comprise slides 1 through about uh, 25. So we'll be going up to linked lists, and this video will cover records, arrays, basics of data structures, memory addresses, allocating memory, changing fields within a record, um, and pointers, and also changing pointers. And I'll be doing this in this video mostly by just going through the slides, simply because there isn't much code to be going over. But these are also important topics that will help us understand the problems that we will be facing in the later chapters. So, how this will look like is that I'll mostly be going through the PowerPoint, and I'll be bringing up different code editors in the case that there are coding problems that we'll be looking at, or the whiteboard to be like drawing diagrams to help illustrate the points that I'm going to be making. In future videos, I plan on taking a more loose approach and trying to build, rather than repeating what's on the slides and trying to drill these facts into memory, I will be trying to illustrate proper software engineering skills, which is mainly problem solving, because on the job, what you'll be doing is you'll be mostly just solving problems, and so you'll be given a problem that comes to you unsolved, and it's your job to figure out how to solve it. And you can certainly memorize how to solve a lot of problems, but eventually you're going to come across a problem that hasn't been solved before, and you're going to have to relate this to problems that you have solved before, and try to solve them. So I think that covers my philosophy on how to solve these problems. So let's dive into it. So data structures. So we can think of data as just information. And so computers have different ways of organizing, accessing, and manipulating data. Arrays and records are like two of the most basic types of data structures. In other programming language, records might be called objects. So we'll be looking at how computers store arrays in memory. I'll be skipping these two slides because they're just telling you that data structures can help you go through data quickly. So this is an example of an array. This array is going to be one index, so the first element will be stored at 1. Sorry, I had to attend something. But yeah, the first element will be stored at 1, and then all subsequent elements will be stored at the next index. So if you wanted to access, if this array 7, 0, 2, -2, 10, 6 was called A, to accessing the first element would be calling A1, the second one would be A2. You can create, so this is how like an array would look like, but you can create different data structures to solve the different needs that you require. So maybe you don't need just straight up numbers, maybe you need words, or maybe you need a collection of numbers and words, and we'll be looking at some different types of data structures. So depending on the problem at hand, you will be using different data structures or different algorithms. So in the case of drawing circles, you might need to know the position. So this would be X and Y, which would be two numbers. But you might also want to know the stroke width, and that'd be another number. I'll be stopping real quick. Sorry, it's been very loud for some reason. That's why the pauses are there. But so yeah, caller ID needs to store different data, like a contact's name or number. So this would be name and number associated. And so we'll be looking at the basics of how a contact data structure would look like. Um, for a caller idea, you can manage your contact list by creating two parallel arrays that have same length, one for names, one for numbers. But you can see that this solution would quickly be pretty bad because you might have cases where a contact might have multiple phone numbers, or if you delete a contact off your phone, this would look pretty weird. So let's jump right into the whiteboard to look more closely at this. So let's say you want to delete Bay. Let's cancel this out. So yeah, so if you would delete the element at here, you would also have to remember to delete another element that corresponds to B at the same location. And so you would have to pretty much remember that. Like, there's no other way other than, when to delete Bia, you would also have to delete this phone number. And that can be pretty tedious. And there are better ways to store relationships between names and numbers. So, come on. All right, I keep getting interruptions. So sorry. So, yeah, so you would have to have two parallel arrays. And over time, this just wouldn't work. And what it would, like, think about the case where you want to add email addresses, zip notes, or a note. You would have to maintain like so many parallel arrays to keep track of all this information. And then you might also have cases where maybe you don't have a phone number for Chang, but you're still using up like this space. This space would have to be like an empty slot in the array. Yeah, so this would be like an empty slot in the array, and this just wouldn't work. So we're going to look at a different type of data structure that can help us index a relationship between these two data structures of names, of contacts, of addresses, and then they would all be stored together. And this would be a lot more convenient to access, and we could also make changes much more easily. So records are data structures where you have multiple fields or multiple values stored together closely, and then accessing these values would be done by calling the keys. So we can think of records kind of as almost like an array, but instead of having numbers for indexes, we would have strings, like keys. And these keys would be usually strings, words. So this would be like an array, and under the name index, you would get Ann. Under the phone index, you would get the phone number. Under the relationship index, you would get friend. So that's what it says here. A record's way of grouping pieces of information or fields together. It contains name, phone, relationship. Yeah, so let's whiteboard this out because I think that would be useful here. And so a record would be something like a key to value relationship. And so you would have keys where you might have, let's make a default object. And so all of this would be under like a contact object, and would have, these would be 3 different strings. So this might be name, address. I'm going to reformat it in a bit. And then relationship. And then these keys would be pointing to different values. And so name would be pointing to a value of perhaps Miguel. Address might point to a value of Main Street. And the relationship would point to a value of friend. And so this would be the key value relationship within contact. So these would be the keys, and these three would be the values. And so when you call this object of contact, and let's just say this would be a contact object in the abstract, but let's say this contact was called contact1 equals contact of Miguel, Main Street, friend. If you were to call contact1 of name, it would give you the Miguel. Or if you would call contact1 of address, it would give you back Main Street. Yeah, and so this is going to be a convenient way of accessing data inside of our record, because it kind of makes it similar to how arrays data inside of arrays are stored. So let's go back to the PowerPoint. Yeah, so as you can see, contains memory. So we can see how records can store data in different contexts, but to look at how this memory is actually stored inside of the computer, we're going to look a little lower level and look at how memory is stored inside the computer. This can be a very complicated subject, so we'll only be scratching the surface. And if you want to know more about this, you'll learn more about it in either your computer architecture class or your operating systems class. But the main gist of it, is that data structures computers store information within addresses. So your computer memory is kind of just like a bunch of boxes, or a bunch of mailboxes, really. And each mailbox has an address, and each mailbox has some information inside of it. And each mailbox can only hold so much information. So the way that your computer stores memory is it essentially has, if we can think of these mailboxes as addresses, computer memory addresses, what your computer will be doing is it will be finding empty mailboxes, and it will just be putting information in it. So it will be putting, if you have a program that's calculating a lot of numbers, it might be like you're putting 8142 in this mailbox. You might put 5 in this mailbox. You might put 3 in this mailbox. But your computer has different ways of remembering which mailbox has what data, or what memory address has what data. But in the real world, in the physical world, really all it is just a bunch of memory addresses and a bunch of numbers inside of them. And so I'm gonna go back to the slide just to make sure that we got everything. Yeah, so they're all in computer memory. And I'm gonna show you briefly how that looks like in the computer. So what like an actual computer address would look like. So this, you won't have to know what this code actually does, but just know that this is assembly language. And I wanted to show you this because this code will show you how the memory is stored in data and where it's stored in data. So these are lists of addresses, and we can see what data is stored at that address. So we can see that at 268500992, at the address plus 0, so at that address we have the number 1. At the next address we would have 1 again. So this is the Fibonacci sequence, so it's storing instances of the Fibonacci sequence. So we got 1, 1, 2, 3, 5, 8, 13, 21, 34. So this is storing the Fibonacci records, the Fibonacci array. And on the left side, if you don't understand this, it doesn't matter too much, but I just want to show you that this is kind of how the data in computer memory is actually stored. So it's kind of like how I mentioned, where you have a bunch of mailboxes and each mailbox holds a number, and your computer is just going to be filling up these mailboxes with numbers. And that's how it's just going to operate. So at this address, you have this many, you have this value, and right now I'm looking at it with decimal values. But if we want to look at how these numbers are stored in the computer actually, because in reality, your computer is running binary, so this is ones and zeros, so it's running on base 2. So we want to look at what the computer actually stores. We can look at the hexadecimal addresses, and we can see that, oh, okay, so this is this address, and then this address has numbers, and then this is in hexadecimal form. So as you can see, the numbers change. So this is A18, but in decimal form it's 25. Sorry for the interruption. Yeah, so in decimal form this is 2584, and that's stored at this address. And if we want to look at the decimal address, we can see it. Again, if this doesn't make sense, I just wanted to show you it, just to like throw cold water on you. So let's go back to the slides. All right. So these are data structures. So the computer finds a spot and it tells us where the new data structures live. So what your computer will be doing is it'll be finding empty spots and putting them inside, putting this data inside. So if we change this program, you don't have to know how I'm changing this, but just know that I am changing it. If we change this program, sorry, I keep getting interrupted. Where were we? So yeah, let's say we change the number. You don't know how to know what this code that I'm running does, but I did change it. So we have a bunch of new numbers, and it's storing these new values in memory. So let's see if we can find where we started, where we left off. Around here. 12193, yeah. And so you can see the computer finds these extra 0 spots, these extra addresses that are empty, and it fills them. And it just keeps filling them. And your computer will manage memory pretty efficiently. So that's how the computer works. So it's finding these locations of empty memory and filling them. So yeah, computer memory consists of sequence of numbered locations. So each one of these little zeros is a different location, and their addresses are over here, but they're going to be indexed like, so this is going to be 0, but this one's going to be +4 from that, and this one's going to be +8 from that. So this address would be 268500992 +4. So that would be 996. Yeah. So let's go back to the code. Let's go back to the slides. So here's an example of a record containing contact information. So yeah, so when you call a contact class, variable the contact does not contain our new contact. It contains the address of which the contact is stored. New contact. Did I miss a part? Oh, okay, I understand what it's saying now. So when you create a contact, you'll have the name and you'll have, this is going to be a pointer. This is going to be the memory address located with its relationship. So in this case, 708's not, it's not going to be the address, but it's going to be a number representing the memory address of the contact information. So this will be a number that points to our data structure, which will then be holding the name, the phone, the relationship that we're looking for. So let's see, does it do it here? It doesn't do it here, but let's whiteboard this out. So here's a record containing contact information. So the contact on 555. Okay. So let's whiteboard this out. So we have this. I believe I have some. I'm just gonna grab this just because it's useful. So yeah. Can I close this? Oh no, I can't. Can't I? Okay, there we go. There we go. That's how I want it closed. So let's move this over here. So we can think of private. We might have their name, the contact. So we'll have, this will be a contact information. So this will be name. This will be name, phone, relationship. And let's move these indexes around. So let's add some space. And so this will be a record, and it will live at a certain address. So let's just fill it out real quick. That's not what I want. Enter. 555 1234. And this will be located at 7801. That will be the memory address it's located at. And so And so we might have another piece of data, which is like mayor name, and then contact info. I might break this up. So we'll have a Jing, and this will be a pointer actually. So this will be a number which refers to the memory address that this record is located at. And so this information, the contact Jing 7801, it does not contain any of this information. What it contains is a pointer that points to where this information actually is. So it's going to point to the memory address at 7801, and then at the memory address 7801, it's going to contain the information that we're looking for. And so we can kind of think of this as a pointer relationship. And so let's go back to the diagram, the slides. And so this is creating a new contact. And this new contact is going to refer to a new object that we're going to be creating. So it will be a new piece of information like this. So that would be like, it would be like this, but if these names were different. So if the address was different, and if, let's just do it here. It would be like, let's copy this. So long. This would be a new piece of information, and this information would be Dawn 555 8998 8998 dentist. And obviously this would be located at a different address. So this might be 7901. And so this new object that you create, if you create a new object, it's going to be like name, contact info. This might be Dawn. And the address would actually be different because we're going to be storing that information in a different memory address. And let's get back to our slides. So these two diagrams, one with the damn, I do not. I should go to this much more prepared. Let's see. Okay, so now that we have the concept of memory addresses storing records, that is objects, and the data inside of those objects, now that we have that understood, we can actually just think of these addresses, whenever we refer to these memory addresses, we can kind of just think of them as pointers. And so instead of having the actual number, we can represent it as a little arrow that points from the the location, like to where the number would be, to the object it's referring to and its place in memory. So when we have a pointer that points from this box to another box, we can just think of this as, instead, this box would just have the address and it would be referencing an object stored in memory. And so whenever we see the arrows, just know that that's what it's referring to. It's talking about a pointer to an object. It's where the object is stored in data, and these memory addresses are commonly represented with arrows. And so that's why computer scientists, they call memory addresses, they call them pointers. So to access the contents of the pointers, we'll use arrows as kind of a shorthand. So maybe instead of new contact dot name or new contact brackets name, it'll just be new contact arrow name, and that corresponds to the value Don, because this new contact is going to have the memory address of the contact. And so when you look at new contact, it's going to, the name field under that will be the name field in that memory address. Let's move forward. Yeah. So in this case, a row, A refers to the memory address 193, and we see at memory address 193 we have two values, row and column, and row has 1. So A row is going to be referring to the memory address that A corresponds to, and the row field. So this will be 1. And in this case, go to the next slide. B row would be the memory address. This would be, B has a memory address of 901, and we said 901. It has a record like this, and the row at 901 is going to be 6. So let's go to the next slide, and let's look at what happens when we change the memory address at B to match the memory address at A. So instead of B referring to this memory address in this record, it refers to this record. And so B row plus A column would actually just be row plus column of this entry, because B row is going to be 1 because this points to this record, and A column, since this address points to the same record but at the column field, a B row plus A column is actually going to be 9 because it's 1 plus 8. So yeah, understanding how pointers work is very important to understand how complex structures, the data structures are designed, and how you can manipulate and change the data within a data structure. So we're going to look at, manipulating records and pointers. So suppose that we want to store mailing address information in a record. For this, we'll create a class where addresses have street nums, a city, and a zip. And so creating an instance of an address would be creating an object with street num, city, and zip, and that object will have a pointer pointing to its data. So this code would create this object in memory. And then a contact would be a way to store data about a contact, but it will have 4 fields. So we'll have the name, phone, relationship, and address. But this address won't actually be this information where it's street num, city, zip. It will actually contain a pointer to an address object or address record that it's going to be referring to. So that's why this address is a memory address or a pointer. and it's going to point to the address record which will actually be containing the street, city, and zip. And we'll be looking at code later on to look at this more closely and understand better. And so this is an example where you're creating an address that it's going to be referring to a record in memory, and then you're going to create X, which is going to be a contact, and this contact is going to have that address record that we just created as a reference, as its address object. So there's going to be a contact record that's going to have name, phone, relationship, and it's also going to have an address pointer. And this address pointer will be pointing to the same address record that we just created. So we just created this record, and then afterwards we created a new record with a pointer that also points to this information. And this is key to understanding how classes work, and it's key to understanding how objects in data work, data structures work, and how objects work. So yeah, this address field is a pointer inside of another pointer. So this would actually be pointing, it's pointing to here, but really it could be, it's more realistically, it's pointing to the pointer which points to the object. So even though these are the same, that's kind of what you should think about it. And since we already have a pointer, the address which points to the address, and we also have the pointer inside of the X contact field that we've created, we actually have two pointers that point to this address record. So we have the address pointer that we created when we made a new addressed object, when we first created and populated this record. And we also have the address pointer inside of the X contact. Hold on. Let's create a new contact for Anne. And so this is another contact where we're doing the same thing. We're creating an address, creating a different address, and we're creating the contact with a pointer to the address that we just created, the address record that we just created. And so same process, we have a contact, we have a pointer to the object. And so to change the address, we would actually have multiple solutions. So you can either go to the contact information and access the address pointer, and that address pointer will then point to the address record, and then you can access the zip record and change it. And so that's one way you can change it from 90919 to 90990. Or you could change the address, you could access the pointer for the address, and then from there you can go to the record, and then you can access the zip and then change it. So that would be this solution. Or you can create another record which will have the updated zip. And so you could create an entirely different record, which would be, let's diagram this out. This would be, we could create another record instead, which would be the same instance where this would be super small, 11 Maple Drive. Let's make this bigger. We could create entirely new record in memory and then just point the new instance. Come on, 990. And then another way we could change this is that instead of having this, we would change the pointer to point to a different one. So we would have, instead of pointing there, we point straight to here. And so that's another way to change the zip. And so creating a new object and changing one value is another way of solving this problem. And so yeah, as you can see, all the solutions work. So commands A and B work by changing the already existing record. And one does this by accessing one pointer, and one does it by accessing the other. And then objects command C works by creating an entirely new record. And now this is the part where we're actually going to be looking at a problem and its solution. So this is the part where we're actually going to be looking at some C++ code. So what did I just do? We were at where were we? We were here. Oh, right here. So, both records are the same address. Okay, yeah. So this is a case where we have two contacts, but they both live in the same place. So we have Anne with this information, and we have Preeti with this information. And when we met them, they actually lived in the same place. So we could actually just reuse the same record for the address for both of them. So we could have just in the field of their pointer, in the address pointer field, we could have it both pointing to the same object in memory. So we point X's pointer to the address record, and we also point Y record, the Y pointer to the address record. But later on, Preeti is actually moving to Chicago to work for Anne, for work, while Anne is staying in the same old apartment. All their information is the same, but her address changes. So we're going to look at how you actually do that, because now we want to be having two different addresses. So this first solution accesses the address record associated with Preeti and then changes it in memory. So this one, it gets the pointer from Y, it finds the record in memory, and it changes each field of the address to the new information. And this wouldn't work because when you change this information, this X, this pointer is also pointing to that. So you'll be changing the information for X and for Anne and Preeti at the same time, because you're changing the record which has multiple tenants assigned to it, pretty much. In this case, you create a new object with the new address, and this also doesn't work because you're not changing Preeti's information. You're not setting Preeti's new address to this address. You're just creating a new address. And that would be just the practice of creating a new address record in memory. But you're not exactly changing Preeti's address pointer to that new record. It would just be a new record in memory. And so the obvious solution is obviously C, where you're creating a new address record and you are setting the pointer, the address pointer at Y, so Preeti's address pointer, to that new record. So we first create a new record. Let's diagram this out. We create a new record. And then we change y's pointer to it. So let's diagram this out. Let's go. Let's create a new one. Let's create a new address. Same case where we're going to be having street num. Let's make this bigger. So we're going to be having street num, having city, and we're going to be having zip. So in this new object, we'll be having the new information. So we'll have 111 Lake Ave, 111 Lake Ave, City of Chicago, and the new address of 60601. 60601. And this command, what it does is it creates the new address, right? So we've created this new address in memory. We go back to the whiteboard. We created this new address in memory. We'll call it address 2. And what we're going to be doing is we're going to be replacing the pointer, the y pointer. So let's see if we can get away with erasing it. Yeah, okay. So we are going to be erasing the current y pointer and changing it to a new pointer. So let's do that. Let's make it black. And let's point it to over here. And we're gonna make this a nice pointer. So this new pointer, we can add more, okay, yeah, this is actually what I want. There we go, and then we move this. We can move this, right? Oh, there it is, there it is. Yeah, so we move it like this, and so this pointer points to this object. Let's make it look like that, because that's realistically what it is doing. It's not pointing to the street num, it's pointing to the object, which is the object in total. So it could look like this, or you can make it look like this. Either should be the same as long as you interpret the pointer as pointing to the entirety of the record rather than just the street num. And so that's how you would properly change Preeti's address, is that you would be changing her pointer. Where did it go? Yeah. So just imagine that why is the pointer not showing? There we go. Yeah. Okay. So yeah, just imagine that Preeti's pointer got changed. We made a new record, and we changed Preeti's address pointer to point to this new record, and that's how we change Preeti's address. And so that satisfies how we solve this problem. So yeah, this is just showing what happens is that you're changing In this case, you're changing the address for both of them. In option B, you're creating a new address, but you're not changing the pre-address pointer to that new address. And then object C, solution C is actually the correct answer, where we're creating a new Chicago address pointer, and we are properly changing Preeti's address pointer to reference that pointer. And let's look at it in C++ code. So we have a address class, which stores some memory. And then we also have a contact class, which stores memory as well as a pointer to the address. And as you can see here, this is how you instantiate the class, and this is how you change the relationships. In the case that you want to be changing the field, so if you want to change the phone number of the contact, the relationship contact itself. This is the print statement for the contact, and this is main. So let's go ahead and compile this code, and we'll see it running. Let's run the compiler. So this would be, I'm running on Linux. I'm not going to be going in depth into how the program runs, because we're just looking, our main focus is just the data structures and the concepts of data structures rather than the code. So let's do just the basic compile commands, which are, you just say G++, hello CPP, this is the compiler, this is the name of the file, this is the output executable name, and this is the executable. Yeah, this is setting the output name of the executable. And once we do that, once we compile the executable, we just run it by just typing ./hello. And we can see we print out the initial case where we're stating the initial contact information, and then we're updating it. So as you can see, we properly updated Preeti's information to this new record. And let's look at the code so we can understand it. So this shouldn't matter because this is irrelevant. That's just showing that we know that the address works properly. Oh, it doesn't. Okay. Okay, so first we create an address where it's going to be, we're going to have an address object of 123 main, Springfield, 12345. That's the record we have here. No, I didn't make the values match, but just imagine it did match. So that would be this case where these records have this information. And so then when we create a contact class, we just reference this address record that we just made. So when we create and when we create Preeti, we save memory by sharing the address of this class, and we can actually print out the address that we're going to be linking Preeti and to. So let's count shared address, and we're going to be looking at the memory address just so we can see, because it'd be useful for us to look at. We're going to go calco. Why is it? Okay. Count shared address. Handle. Alright. And let's just see. Let's just look at the address just to see, just so I can show you that it's just going to be a random number. So yeah, look, we got that's the random address, and if we call it, if we were to call like the address itself, it would just print, you know, that would just be the record in memory. Let's see if we can actually. We have print functions for our address, right? if we were to call shared address dot display address, this would actually print the address at that memory location. So let's recompile it and let's see it print. And we didn't get any errors. So yeah, so what's happening in the code right here is we're first printing out the shared address in memory, and then we're getting that memory address and we're calling the print statement for the address. So we are accessing the data, and we didn't add a print line, so it didn't really print out for us. So let's try, instead of using our nice print statement, let's try just getting the city just straight up. Let's see if that works. So let's try get city, and let's see what that gives us. Oh shoot, sorry. I gotta recompile it first, and then I gotta compile the executable. So February. What? It says wait, hold on. Why does it say February? Get city. Why does it say February? I don't know. Wait, I think it just doesn't print the address. I think that's the case. Oh, I'm just thinking that it says address, but we're just not printing. That's the case, because that's not a print statement. Let's do that, and then let's do endl. So let's see, right? That's how you do it. Yeah, there we go. That's how it works. Yeah, so in this case, we were getting the string Springfield, but we weren't printing it. Everybody makes mistakes. So yeah. I'm going to upload another video where, actually, this video is super long, and I didn't mean for it to go this long. I think it's just because this is the first video, so we'll be, I'll be getting better at this as I do more. But this is just video number 1, so I suggest going at 2 times speed. And it will get a lot better in future iterations. I think I just went into this one without planning anything, but I think in the future videos I'm going to be breaking it up, where I'm going to be recording a few slides, pausing, collecting my notes for the next few slides, and then recording that next bit. So I'm going to be doing actual editing rather than this is just it's really just one take. I think that some pieces were important to go into depth about, like memory addresses and such, because these are very important concepts, and they are not necessarily ones you can go by really quickly, but there are definitely slides where I think I took too long, and I kind of do want to be playing around with this C program I made to show you, like, you know, what happens when we do this, what happens when we do that. So yeah, this is just proof that, you know, we have a record in memory and we're printing it. So let's play around with it more. So as you can see, we're initially we create an address and we create 2 contacts, and each contact is going to have the shared address. We display the initial contact information, and they both have the same address. We create a new address for Preety, so we make a new object in memory. So if we actually print out this new address, we can see that we created an entirely different address. So new address for Preeti. Then we're going to just count Preeti new address handle, and we can see when we run this, and let's delete this information where we're just printing out the city. When we recompile our code, the memory addresses for the different records are going to be different. So this, originally they had a shared address of this, and when we create the new address object, we have a new address of this. So completely different addresses, and then what we do is we set Preeti's address object, address pointer, to this new address. So if we actually run and.print, if we print just their addresses, can we get their just addresses? Okay. At the end of the program, if we run count and.get address handle, and we run Preeti.get address handle, we can see that they have two different pointers. So let's run our program again. So yeah, we got two different memory addresses, and that's kind of what I wanted to show you. Sorry it took so long. Make sure to watch this at 2 times speed, and definitely the next few videos are going to be a lot shorter than this. I did not intend for this one to go so long, and I'll definitely be rewatching it to figure out how I can do a lot better.